All right, this is 3.4. We're talking about finding real zeros of polynomials. This is video number 2. So if you have not watched video number 1, go back and watch video number 1. So this is continuing our notes. So there's a mathematician that came up with a little rule, and Descartes is how you would kind of pronounce it. And so Descartes' rule is how you would generally pronounce this for the actual rule. So what it basically, he noticed something that when you have a polynomial and the signs change, he notices something that happens with the amount of zeros that takes place in the polynomial. So notice, here's an example. So I have p of x, and notice it starts off positive here, and then it goes to a negative, and then it stays negative, and then it goes to a positive, and then it stays positive, and then it changes to a negative. So notice that it's actually changing signs several times in that, and that amount of times that it's changing, you could see something happening. So notice it's happening 1, 2, and 3 times. And so that 3 is going to play a role in how many zeros there's going to be. And we'll talk about that on the next page. So here's another example. So notice this polynomial, they're all positive, so there are no variations. This goes from positive to negative, so there's one change. Again, positive to negative, stays negative, and then goes back to positive. So there are 2 changes of signs in that. So let's look at actually what he came up with as the rule. So if P is a polynomial, so the number of positive real zeros is equal to the number of variations. So it's equal to the number of variations in sign, or is less than that by an even whole number. And then he noticed that too. So that's positive real zeros. And then there's the negative real zeros. So there's 2 things you got to pay attention to: the positive amount of real zeros and the negative amount of real zeros. And this is equal to the number of variations in sign of p of negative x. So this one's a little bit more intensive to be able to do that. And then that will tell us the amount of negative real zeros in the polynomial. So let's look at an example. Notice this one right here starts off positive, then it goes to positive, then it goes to positive, then it changes to negative, and then it stays negative. So it changes 1 time. So notice if it changes 1 time, so on number 1 it says the number of positive real zeros is equal to the number of variations in sign, so in p of x, or is less than that by an even whole number. So notice you tell right off the bat that there's going to be one positive real zero. So 1 positive real zero. Now, the part where it says p of negative x, so if we take p of negative x, so we substitute negative x in, I'm going to erase this. And then if we simplify this, it's going to end up getting to this. And notice now let's look at the signs, the change of signs. So it starts off positive, then it switches to negative. It stays negative, then it switches to positive, and then it switches to negative. So notice on here, there's 3 changes of sign when we take p of negative x in. And notice what, according to the rule of sign, so this will have 3 or 1. So notice this says or is less than that by an even whole number, or an even whole number. So this literally will have 3 or 1 negative 0. And this, remember, this had, when we did this originally, this had one positive 0. So altogether, it's possible that this has 3 for this one and 1 for this one. So it could actually have 4 zeros, or if it has 1 negative 0 and 1 positive, so it could have 2 negative zeros. So zeros total. Now, if you look at this graph, if you actually look at this graph, and I took a picture of on a graphing calculator so you can see it. So notice if I did graph this function, I have it over here to the right. notice I have, I end up having one positive 0 and I have one negative 0. And then, so that's really what I'm looking for is the amount of positive zeros and negative zeros. And that's what the rule of signs tells us. All right, so one last problem. If I wanted to factor this problem from the very beginning to the bottom, to the very end, I really want to factor this. And so what you're going to do is, this is all inclusive. So you can use the rule of signs, what we just now did, and notice it changes signs from, it starts off positive, then it goes to negative, stays negative, it goes to positive, then stays positive. So notice you can find out how many zeros there's going to be, positive zeros, and how many negative zeros there's going to be in your answer. And that may help you, by the way, when you're doing synthetic division, because then you'll know, once you found two positive numbers or three positive numbers, then you can easily then, oh, now I just need to use my negative numbers to try to find your zeros. So what we're going to do is do P over Q again, and write all the possible zeros, possible rational zeros. And so the Q and the P. So plus or minus 1, these are possible factors, plus or minus 3 and plus or minus 9. And then plus or minus 1 and plus or minus 2. And then we're going to do P over Q. So P over Q, write all of those. So I found all the possible rational zeros. So what we're going to do is I start off usually with 1. And so I'm going to start with synthetic division. So 2, 5, negative 8, negative 14, 6, and 9. And I'm going to start off using 1 and then negative 1 and see which zeros I can do. So bring 2 down. 1 times 2 is 2. That's 7. Remember, just multiply, add, multiply, add, multiply, add. So that's 7. That's negative 1. 1 times negative 1 is negative 1. That's negative 15. 1 times negative 15 is negative 15. That's negative 9. And 1 times negative 9 is negative 9. And that's going to give me 0. So I found a 0 on the very first try. So again, if you're keeping track, 1, 0 is what I found. So I have right now x minus 1 is a factor, okay? So because I found 1 as a 0. So now I'm going to start off with 2, 7, negative 1, negative 15, negative 9, and I'm going to use synthetic division. I'm going to try another number. I'm going to try negative 1. So 2, and again, multiply, add, multiply, add, multiply, add. So that's negative 2, that's going to give me 5. Negative 5, negative 6, positive 6, negative 9, positive 9, and 0. So I found another one. So negative 1 is also a factor. So I'm going to keep track of my factors. I'm keeping track of my the numbers that I try over here on my XY chart, so I don't have to repeat things. So now notice I started off with 5th power. And this, once I did it once, that's to the 4th power. And this, I did it again, that's to the x cubed now. And I need to find one more 0, and that will, remember, get it down to a quadratic. Once you get it down to a quadratic, then you can factor. So now I'm going to try 2, 5, negative 6, and negative 9. I'm going to try it with one more, hopefully a number works. So I'm going to try negative 3. So if I bring this down, that's going to give me negative 6. Add that column together, that's negative 1. Multiply, multiply, add, multiply, multiply. Multiply, add, multiply, multiply, add. So 3, that's going to give me negative 3, positive 9, and 0. So I found another 0, which means x plus 3 is a factor. And notice this is now a quadratic, so 2x squared minus 1x minus 3. And if I factor this factors to that. Yeah, no, I was just double checking. So this is 2 factors, and I already have these 3 factors. So the entire answer is 2x minus 3, x plus 1, x minus 1, x plus 1 again, and then x plus 3. And so notice that this has, especially the x plus 1, it's being repeated twice. So here I factored the x plus 1. Here I already have an x plus 1. So it's being factored twice. And then if I ask you to find the zeros from there, you can find the zeros. This is -3 as a 0. This is +1. This is -1. And this is +3/2 if I found the zero. So it actually has 4 zeros in that. And again, if you notice at the very beginning, I mentioned about Descartes' rule of signs. So if you remember how many times it changes, it starts off with positive, and then it changes to negative, and then it changes back to positive. So it changes twice, which means I could have 2 positive zeros. And notice I do have a +0 and I have a +0. And then if you go back and change the x to -x, you'll see that there's 2 possible negative zeros. And so the rule of signs does apply here as well, and that helps you narrow it down as well, just to double check. So that's the lesson of 3.4, finding roots of polynomials.